Welcome back, ladies and gentlemen. Today we're going to take care of 7.5 and 7.6 together. We're basically going to do a full rundown of trigonometry in one day. So, as per usual, up on the screen, you will see your exit question for the day. Now, we've talked a little bit about trigonometry and just what to expect out of it. A lot of students actually like trigonometry because it unlocks everything that you need to know about a triangle. Up on the screen, you'll see the very basics of it. We're going to start with a right triangle. And one of the new things that might be new and fun for you is the new symbol in the lower left-hand corner called theta. And theta is going to be used instead of x or y as kind of our generic variables. Usually when we use a theta, we are referencing an angle measurement rather than a distance or a number. Another one that we'll reference quite often will be called phi, and it's basically a theta turned 90 degrees. But if we draw a right triangle and label one of the angles theta, then we have a triangle for which we can reference the rest of the triangle in reference to theta. So one of them you already know, the hypotenuse. We can reference the hypotenuse at any point, and if we compare it to where theta is, we can say the far side is called the opposite side and the near side is called the adjacent side. And all of a sudden, a whole bunch of light bulbs should be going off in your head and saying, hey, I've already learned this, possibly in 7th grade, I believe, and where we learned about SOH CAH TOA, and you'd be absolutely right. Now, what SOH CAH TOA is, if you have forgotten, is SOH CAH TOA is a mnemonic to help you remember the three basic trig functions or the trigonometric functions that have to deal with the ratios of sides of a right triangle, where sine stands or gives you the ratio of the opposite side over the hypotenuse, cosine gives you adjacent over hypotenuse, and tangent gives you opposite over adjacent. Below or in the middle, you'll see each of these functions spelled out in their entirety. That's as long as they get. But you'll notice that if you're looking at your calculator right now, they are abbreviated. Now, what I do want you to notice is that this is sine, not sin, and this is cosine, not cos. All right, and that's tangent, not tan. Okay, so they have full names. When you talk to me in class, I expect you to use them, and just know that they are abbreviated on your calculator and in your work just because mathematicians are lazy and or we needed to cram something on a calculator button. But the sine of an angle, theta, is equal to the opposite side divided by the hypotenuse, or the length of the opposite side divided by the length of the hypotenuse, and so on and so forth down the road here. Cosine, adjacent over hypotenuse, tangent, opposite over adjacent. We have this mnemonic for you because it's easy to memorize, and therefore you need to memorize it. So if you don't have it memorized, take a moment and just jot it down. All right, now let's just talk about one of them. Let's talk about sine of theta, which is the opposite side divided by the length of the hypotenuse. And I just want to show you the magic behind these, which relates to what we were talking about with similar triangles. So in here I have a sketchpad document where I have built a right triangle and I have calculated each of the trigonometric ratios. So this would be opposite side over hypotenuse. This would be adjacent side over hypotenuse. This is opposite side over adjacent side. And then down below, you've got the actual measurements of each side and probably most importantly, the measure of the angle A, which is in our case theta. Now, what we learned about similar triangles is that all the angles are always the same. And this is true. So if I take this triangle and shrink or grow it, you'll notice that the measure of angle A does not change as noted down here. But you'll also notice that as I change that, the trigonometric ratios do not change as well. And that basically tells you that for a given value of theta, the trig ratios are locked in. And that's one of our properties of similarity. We can always compare the ratio of sides, and that ratio will be the same so long as the shapes are similar. Well, when I click and drag on this, all I'm doing is creating a whole bunch of similar triangles, and it would make sense that these are locked in. Now, it's not just that simple. These ratios will not always be the same, because if I take and change theta, those ratios do change. However, for any given theta that I lock in, no matter what size the triangle is, those ratios will always stay the same. And you can use these to set up and solve equations. Well, How do you do that if you don't know this number right here, that 0.88? Well, the cool thing is you don't have to figure that out. You don't have to know how to calculate that. You barely even need to know where to find it. And the answer is it's built into your calculator. Now, back in the day, they basically made this giant dictionary of trig ratios down to any hundredth of a degree of theta, and you would have to go page through this dictionary to go find the trig ratio for that particular day. But that is built into your calculator now. You'll see that you have a sine, cosine, and tangent button on your calculator, or at least you should. In other words, at this point in your math career, you now need a trigonometric capable calculator. Now, if you do not have a trigonometry capable calculator, you need to go get one. They're about 15 bucks at your local Walmart, and all you're looking for there is sine, cosine, and tangent, and the three functions up above it. And they are abbreviated sine, cosine, and tangent, SIN, COS, and TAN on your calculator. How do you use them? Well, first off, there are a couple ways to measure angles, and you just need to make sure that your calculator is in degree mode. That means that it is not in radian mode or gradient mode, and I believe the way you deal with this on the TI-30X IIS, which most of us have, is to play with that button right there, that degree button, and if you press that button, it'll come up with a menu, and you need to make sure that it's in degree mode. So you can see that we have an equation that's basically set up. The sine of the theta will equal the length of the opposite side divided by the length of the hypotenuse. We'll shorten that up a little bit. We'll use the actual sine function with a set of parentheses. Always use parentheses. And we'll just use O for opposite and H for hypotenuse. And if I tell you any two of those three, you need to be able to solve for the third. That's why we're doing this all in one day rather than splitting it up into two. So there are three possible pieces of information that I could make you solve for. One would be if the opposite side is missing, one would be if the hypotenuse is missing, and one would be if the angle measure is missing. So you need to be able to set up and solve equations to find all three of those. More importantly, you need to solve all three of those. So up here on the screen, I have all three of them written out for you. I'd like you to pause the video, just copy them all down, and I will show you how to solve each one of them separately. So the one on the left, the only thing that's really tricky about it is that you have this new word, more or less, sitting there, and you're not really, at this point, free to recognize that just sine of 30, that's a number. Your calculator can do that for you. If having those words in your equation bother you, you can type in sine 30 on your calculator and you'll get 0.5, okay? But just treat this whole thing as a number. And then from there, it's actually pretty easy. You have your variable being divided by something. So in order to undo that division, you have to multiply it. So in other words, you multiply it by 2. Or you can think of it as a cross products problem where you just crisscross and set them equal to each other. And then we have our variable all over on one side all alone, and we have these two things over on the left-hand side, which may not to you right now look like it's solved, but it is in fact, because if you type in 2 times sine 30 and then close your parentheses on your calculator, you will get a number. And if you're doing this right now and you're following along, it might be worth it just for you to type in sine of 30 and make sure that you get 0.5. That will ensure that you're in degree mode on your calculator. And if you're not in degree mode, again, you need to be in degree mode to get these correct answers. Otherwise, you're going to get very far off answers. But anyway, do a little arithmetic there and you get x equals 1. On to the next. So here we have our variable down in the bottom, and there are two ways to solve this problem. One is to think of it as a cross products problem where you just simply multiply the means together, set them equal to the extremes. So you go 1 times 1 equals sine 30 times y, and then recognize that this is a number, so you can then divide the equation on both sides by that number. Right? It's 1/2. So you divide by 1/2 and you get y equals 2. The second way to solve this equation is to use one of your properties of proportion equations, and it happens to be pretty quick, so this is why I mention it. And one of our properties said that we can switch the means, but more importantly, we can switch the extremes. So if I took this y and put it where sine 30 was, and took that sine 30 and put it where the y was, I would have y all over there by itself, and I would have 1 divided by sine 30 over on the other side of the equation. And you can see if you just rearrange that equation, you actually just have all straight up numbers on the right hand side. So type it into your calculator, 1 divided by sine of 30, making sure that you're making use of those parentheses as shown there. And you should get an answer, again, y equals 2. Now this one over here is different, okay? Sine of theta could be any number between -1 and 1. And over here you have a number. So you might be thinking to yourself, how do I get rid of that sine function right there? Well, you may have spotted it earlier before when I was showing your calculator that you not only have this sine, cosine, and tangent function right here, but up above them as a second feature, you have the inverse sine, cosine inverse, and tangent inverse. They are called inverse sine, inverse cosine, or inverse tangent, also known as arc sine, arc cosine, or arc tangent. And they're denoted with this little -1 as a superscript on the calculator. And basically, they are to the trig functions what multiplication is to division, or vice versa. In fact, in the way that multiplication undoes division and division does multiplication, undoes multiplication. So these trig functions undo each other. If you want to get rid of a sine function, you can take the inverse sine of both sides of the equation. And if you want to get rid of an inverse sine function, you can take the sine of either side of the, or both sides of the equation. And these two functions, or these pairs of functions, undo each other just like addition undoes subtraction, etc. So if we go back to our equation, we get this equation set up, and I want to get rid of that sine, so I'm going to apply the inverse sine function to both sides of the equation. Now I'm going to write this out, and I am going to require you that you write this out, and it looks a little ugly. It looks more than a little ugly, but it's functional. Check this out. You've got sine and you've got inverse sine. Now that looks messy, but it's not. This function undoes this function, just like a square undoes a square root, and all that's just going to drop out of this is going to be a theta. And over on this side, well, that's just calculator work. So you can say, calculator, second inverse sine of 1/2. Close your parentheses, make sure you close your parentheses, and you will get an answer of 30 degrees, just like that. Which makes sense because that's what we got on the first couple problems. All right, let's apply it. Here's a triangle. Take a moment, pause the video, draw it, label it. What I want you to try to do is I want you to try to write two trigonometric equations that will help you solve for y and h. Pause the video and try to do that. Okay, here they are. I used a tangent function and a cosine function, and you might have been tempted to use a sine function. So keep in mind that the only angle that we know is 48. And if we reference this as our angle theta, then we have an adjacent side right here, an opposite side right here, and a hypotenuse side right here. So if I wanted to find, say, y, I would have to reference that against something that I know, like 10.2. So in order to find y, I have to go opposite and adjacent. So that would be a tangent function, opposite over adjacent. So I use the tangent function to set that up. I say the tangent of 48 degrees is equal to the distance of y divided by 10.2. Over here, I've got a cosine, or I'm hoping that I'll get my hypotenuse out of the deal. Well, there's sine that references the hypotenuse, and there's cosine that references the hypotenuse. So if I want to find the hypotenuse, I have to go 10.2 over h, which is a adjacent side over hypotenuse side, so that would be cosine. Each of these can be solved. That's a number that your calculator can do. Right here you have a variable being divided by 10.2, so just multiply both sides of the equation by 10.2. And again, this is all calculator work, and you'll get y equals 11.3. If you go through the extra work to show me what that trig ratio is, I ask that you at least go 3 digits. These things have to be very precise to get the correct answer. Otherwise, you can skip directly from this line to that line, and I'm fine with that. Over here, we have our variable down on the bottom, so we can perform the old switcheroo, just swap places, or you can set it up as a cross products proportion equation. Either way, you get an expression that looks just like that, and that is all calculator work, 10.2 divided by cosine of 48 degrees, and there you go. H is 15.2. Now, if you wanted to check your answer, you could plug in 10.2, 11.3, and 15.2 into the Pythagorean theorem, and it should work out. Over here, we've got a new problem. Pause the video and see if you can write two trigonometric equations that will help you find theta. And like I told you before, that's one's going to be called phi. All right, in order to find theta, we're going to have to reference two things that we know. And the two things that we know are the hypotenuse and the opposing side. And you go look at your trig functions, you say which ones reference the opposite side and the hypotenuse. Well, that would be a sine function. So we're going to use a sine function to deal with theta. And if we have phi here, well, in reference to phi, 3 is the adjacent side and the hypotenuse. So that's going to be a cosine function. So if we set up both of those equations just like that, we get this answer or this equation set up. And now we need to apply those inverse trig functions to get rid of the cosine and the sine function. So we're going to apply the inverse cosine function here, and we're going to apply the inverse sine function here to get rid of both of those. And if we do that, these two will cancel each other out and drop out a phi. These two will cancel each other out and drop out a theta. And over here, that's just calculator work. So you do that and you get phi equals 53 degrees and theta equals 37 degrees. Again, that's just you typing in second inverse sine 3 divided by 5 closing parentheses. And again, it's something you can check to make sure that you got right. 53 plus 37 plus 90 is 180. And we know that the angles inside of a triangle should add up to be 180. And that's all there is to it. So you'll get directions that say solve the triangle, and that just simply means give me all the lengths and give me all the angles that are there in the triangle. And with these trig functions, it's pretty short work. I want to give you just a couple hints, just a couple of rules of thumb to help you navigate these problems a little bit easier. First off, if you find yourself writing down a number or a number that has been multiplied by a trig ratio, you need to go to at least 3 digits, and that might even be a little conservative. 4 or 5 would be better. The problem with these ratios is that they all, well, the sine and the cosine ratios all lie within -1 to 1, so they have a very narrow range. So the precision on these things have to be very, very high in order to get near the correct answer. If you're off by just a little bit, your overall answer can be off by a great deal. So it's very important to be high precision. So it's not out of question to carry this out to be 5 digits. Check your answers. Triangle sum theorem, I just showed you how to do that. Pythagorean theorem, I just showed you how to do that, or just taught you, or just referenced how you would do that. And the triangle inequality theorem, which just simply states that the sum of any two sides of a triangle has to be larger than the third. Just make sure that that's true if you ever solve a triangle for all of its lengths. Make sure that your calculator is set to degree mode. Be aware that I believe the default setting, so if you reset your memory on your calculator, I believe the default is radians, which is not what you want. So you're going to have to get used to just checking to make sure that your calculator is in degree modes. And then finally, you heard me say it several times during the video, but whenever you use a trig function, make sure that you close those parentheses just like you would on a square root function that's built in on the calculator. Doing those few things will help you out an awful lot. I think you're going to come into class tomorrow and rock it. I will see you then.